name's Niall. Thank you for attending my session on slowly changing dimensions made easy with durable keys. The session is pre-recorded, so just ask any questions in the chat window and I'll try and answer them, or you can chat to me afterwards. Thank you. Right, so let's get into the slides. So we're doing slowly changing dimensions today. This is a little bit about me. You can contact me on blog, LinkedIn, Twitter, and I've been doing data warehousing, BI, and now kind of analytics in the cloud for sort of 10 years or so. So anyway, introduction. So today we're going to be looking at durable keys as a design pattern to help simplify using slowly changing dimensions for users, making it simpler for them to help with performance of certain types of query. So the idea comes from Kimball Design Tip 147 back in 2012, and basically it's not really something that's mentioned in their data warehouse toolkit book. It was something that came along after and is in a few different places within our website. Is this still relevant to the cloud? Yes, most data, even if we're using data lakes and kind of all these fancy new cloud tools, still ends up in a data mart because the reporting tools like star schemas. The other reason that it's still relevant is because this can help with certain types of query performance by simplifying those queries. And when we're in the cloud, we can assign a real cost, an actual monetary amount to how much a query is costing. So if we've got queries where people are joining in certain ways and we can eliminate that, we can actually work out exactly how much we're saving. So these are the things that we'll be covering in this session. What's the problem we're trying to solve? How is it solved at the moment? Is there a better way of doing it? How can we implement it? And we'll have a demo for that. And one final thing to note as well is this is a lightning talk, so you will kind of need to have some background knowledge around how Kimball star schemas work. So, okay, kind of bit of background here. Businesses generally tend to deal with sort of three types of data. We've got as-is data, that's show me data using the dimensional values, the descriptors as they are now. We've got as posted, so that means that the fact values, the actual numerical things we're trying to measure, are linked to our dimensions, and they will show us those dimensions as they were at the time they were recorded. And then we have as of reporting or views on that, which is kind of like, we're at the beginning of the year and somebody says, well, I want to see all of my data from last year on the structure, the reporting structure that we had as of the end of the year. So essentially there are things that we might want to look at in terms of either current or historical views. So examples of things that change over time is maybe your customer address or your organizational hierarchies will change. And we store these in slowly changing dimensions when they need to change. So we've touched on these two. Organization hierarchies, typically people want to see their data at a high level for sort of leadership, managers and things. They want to see it on the descriptors, the hierarchies as they are now. But for example, if you've got an employee and they've been in a team for 11 months of the year, and that team belongs to a department that's performed really well and their bonus is dependent on their performance, but also their teams and their departments, and they get the opportunity to move to another team because it's their dream job, but maybe that team is not performing as well or the department's not performed as well. They don't really want to see that their bonus is affected. They've been on the team that's done really well for 11 months, but if you look at it just as it is now, then they might not get their bonus. So they'd like people to be looking at it from the perspective of as it was at the time that the numbers happened throughout the year. Another one is customers. So we'll be looking at customers for sales. We bucket them up in order to do analysis on that. So we'd have dashboards that might tell us, for the people who are spending money, what buckets do they fit into? Are they a regular customer? Are they an irregular customer? Do they order at certain times of the year, like birthdays? But when we look at that and we have people within the business who want to analyse it and try and convert someone who doesn't order stuff very much into somebody who orders a lot of things, i.e. makes more money, to target that effort of converting them, we want to make sure that they're using those historical values. So, quick overview on SCD types, slowly changing dimension types. We've got type 0, we don't update the data. Once we insert the data into the dimension, it stays as is forever. Type 1, we just overwrite it all the time. Anytime it updates, we have the newest version. Type 2, we basically put the data into the dimension, and each version of the data has an effective end and effective start. And we also have an indicator that tells us, is it the current row? And essentially, when we get new data, if it's changed, then we mark the old row as being obsolete, we insert a new row with a new surrogate key, and we end up with the historical version being there for the old facts, and it's linked to that surrogate key for the old one. And then as new data comes in, it gets linked to the new version. And then we have type 3. So this is a way of storing a limited history. So we might have, for example, similar to a type 1, the current version, but we'll have some columns that will track the previous version. So as we update the dimensional table, we copy the old values into the previous version columns and then update the current version with the new data. And then just to cover the types of keys quickly, so our surrogate keys are assigned within the ETL or ELT process. The fact tables link to these particular keys. And it's really important that we assign these because the business keys or the natural keys, which identify a row from the source system, can be unreliable. So if you've got a customer that's identified by email address and that email address changes, then that means that we need to be able to deal with that ELT process, but that key isn't reliable across history. Also, they're often in composite keys, so we'll often store the source system along with the source identifier. So a quick example of a slowly changing dimension type 2. Essentially, we've got new data coming in, and we check to see if it matches any existing rows on the business keys. If it doesn't, we add a new row. If it does, we look to see are the columns that we're tracking changing, and if they have changed, we mark the current row as obsolete, and we set the effective end date, and we set the is current flag, and then we insert a new row, and the effective end date is set to a kind of magic date way off in the future, and that's now the current date. And if new data is inserted into the fact table, it's linked to that new row. Okay, so what's the issue with this? Well, often business users will not quite be sure whether they need as is or as posted views. So often they'll know that they need to see the current view, and we implement the type 1, slowly changing dimension. Essentially, they only get the current view. Sometimes they say, well, we need it as it's posted, and then you give them that, and they say, but we also need to see how it is at the moment. So changing the model later is expensive, and adding in both a type 1 and a type 2 slowly changing dimension for the same entity, i.e. for customers, is quite a lot of overhead to manage that. We need to make sure they're synchronized together properly and that everything's correct. But making all dimensions slowly changing type 2 dimensions is really expensive too. Development's more complicated, we need to make sure it's working correctly, and we need to test that. And then viewing the data to get to the current version is more complex. We have more complex queries because what typically happens is we join the data to the dimension using the surrogate key. That gives us the historical version, and then we join that dimension to itself using the business keys to find the current version. But we know that those business keys can be unreliable, so that can be problematic. And it leads to an approach where sometimes users find it difficult to query that data in quite the way that they want to. So we can extend that type 2 and make it type 6 by adding extra columns, a bit like the type 3, to track the current version on the dimension itself. So the type 2 dimension essentially has current values and it has historical values, and every time the rows, a new entity, new version of an entity new version of a customer comes in, we essentially go back and we update all the historical rows in order to say this is the current version of them, and then we don't need the extra join. There's obviously an overhead and there's a lot more code in the ELT to make that right and go through and we can check it. So, okay, so extending the type 2 to add the durable keys to try and make this a better solution. How can we do this? So the idea of type 2 with durable keys is that within the different versions for a given entity, for example customer, each one will have its own surrogate key. What we would like is to have a surrogate key that exists at the entity level. So all the different versions have their own surrogate keys. They have durable surrogate key, which is like an extra surrogate key, that is for that individual customer, cross history. And that should have some nice properties. So it should be assigned by the ELT or ETL process. It shouldn't be a smart key. It should be definitive. It should be there all the time. It's never missing. It's always there. It shouldn't be a smart key, therefore we can make it minimal, we can make it an integer, so it joins nice and fast and takes up a small amount of space on the fact tables when we link to it. And it should also be consistent. It doesn't change. Once it's there forever. And it should be unique at the entity level. So, for example, a customer has a durable key, and that should not be the same for any other customers. And then from a pattern of it, point of view of implementing this, we should be able to make it like a design pattern. So we should be able to retrofit it, but it should be simple and easy to implement on our new code and new projects. And it's sometimes also referred to as an SCD type 7. The SCD type 7 is on the Kimball site in a few places, but it's not as well known as the SCD2. So here's the example we had before. And here's the example as we change this to become an SCD type 7. So what's happened? Well, when we've detected our changes for our updates, before we could do the mark the old one as obsolete and insert a new version in any order we wanted. What we want to do here is use a technique where essentially, as we mark the old one as obsolete, we can push the durable key that we already have into the new row that we're going to add. So we can see here in purple we've got this new row, this durable key highlighted, and as this new green row is inserted, it picks up the durable key that was there before, and that's assigned. Okay, so how could we implement this? Well, we keep assigning our surrogate keys like we normally do with identity values. That keeps them as nice sequential numbers that are just automatically assigned. We'd like to be able to do the same with durable keys. So if we use a sequence object introduced in SQL 2012, we can essentially have something that will assign us new values in a sequential order. It works with transactions and all of that good thing, those good things. But it's able to do this in a way that we can use it within a default value. So when we declare our table, we can say, if we haven't got a value, grab the next one from the sequence. We can also grab the next one from the sequence within a query. So if we've really got data in there and we want to retrofit this, we can update all of our existing records. We can group them by the business key, how we know that the business keys work together, handling things like email addresses that have changed for a customer, that's the business key. And we can assign a durable key to those groups of historical rows at a per entity basis. But the nice thing about doing this is it's not an identity column, so we can overwrite it with whatever value that we need to. And the uniqueness is enforced using a unique index, and we can add a view over the top, which essentially gives us a type 1 dimension for free. And then the fact tables can just reference this durable key and they can join directly to it. Okay, so now we'll move on to a demo. Essentially we have a small star schema here, and it's a sales table that links to a customer and a product, and also to a calendar dimension. So essentially it's a very simple star schema, and we can just go from there. So onto the demos. Here we have some demos to show the usage by end users of the durable keys and how they access the SCD Type 7. So we have the first script here. All of these scripts on GitHub, by the way. So the first script just sets up that star schema we saw and adds in some sample data for us. So I've already run this, so the database is ready to go. So here we've got two different notebooks in Azure Data Studio, and we're just using these to compare the queries. So the first query is exactly the same. This just kind of shows us what the data looks like. So within here, we've got some product categories, some customer categories. They've both changed throughout the year. So our product categories, we've got an old tea category, which has been split to tea bags and loose leaf tea, and some of our customers have changed category. That just gives you an idea of what the data looks like. So for the first query, we're querying the as posted data for the pricing information, and we're going to use that in comparison with the price paid on the fact to work out the discount. And then we're looking at the product current value to give us the product category, and we're getting the customer current value to get the customer category. You can see here we self-join those dimensions to each other on the business keys to get the current row. So if we run that, we can see the results. Now, to do the equivalent with our durable keys, we simply join to the product to get the historical as posted using the surrogate key. We join to the product current view, which is already filtered to the current values for us using the durable key, and the same with the customer current view. So that simplifies that query somewhat and removes one join. We can see the results are the same. If we want to look at the as was view of the data at a certain point in time, so in this case at the end of May, we would do the same, but we replace the is current row for a type 2 SCD with the date range we need. So we've done that for both the customer and the product to get the as was at the end of May view. We can run that. So we can see that before we had advocate, irregular customer, and now we've got irregular customer, super customer. So we can see it's a different view of the data. To do the same with the durable keys, we pull from the actual main dimension, but we join on the durable key instead of the surrogate key, and we've now added back in the same date range because we're not pulling from the view that limits to the current data, and we can see that the data is the same. Okay, for our second demo, we have a separate setup script that creates as a database without the durable keys, and we're going to see how we can add this to an existing star schema. And then we have another notebook. These are both in a separate folder in the Git repo, and this will show us how we add them. So firstly, we're going to add a sequence. It starts at 1, increments by 1, and to the customer dimension, we add a new durable key column, and we add a default to set it to the next value from the sequence. This won't actually add anything to that new column, so we need to go through and update it. So we simply get the unique values from the customer in terms of the business keys, and we group by them, and then for each one of those individual items we get a durable key. We then use that to update the customer dimension, and we can see that we now have durable keys on there. The reason we did it with a temp table is get next value from a sequence doesn't like to be used with an update. Okay, now we can add we can update the column to make it not nullable, and we can add a unique index for the current rows to say that the durable key must be unique for that. Okay, so now we have some data that we want to merge in. So we have a statement that can be used in a very similar way for SCD2. Essentially what we have is a merge statement that looks at the business keys, and if they don't exist it inserts the data, and if it does exist and it's changed, then it's going to do an update to set the valid to date to be yesterday, and it's going to change the is current row to be 0. It then outputs the results of that so that we can use it for the input to an insert into. So if we filter to where the merge action was updated, then we can simply say, so for these records that we've just end dated, insert a new record. Does it that one to update and insert in a quick hit. The magic for this comes from looking at the inserted magic table that comes from merge, and from there we can actually get the durable key that was on the original row, and we can use that for the insert. So we can see the 4 lines that have been updated for this, and when we run the cell we can see that the updates have come through. We have our new special customer here, and we have an update for myself, and we've picked up the original durable key, but we've given a brand new durable key to our new customer. Okay, the previous demos we saw that we had a view, customer current. That's just a very simple view. We select the durable key and the customer attributes where it's the current row. And we can add that in very easily. And that gives us the equivalent of an SCD1. So finally, we might want to update our fact table to actually add the durable keys in. So we do that simply by joining the fact table to the customer using its normal surrogate key, and that returns us the durable key. We can use that in an update statement. So when we run this one, we filtered for a few customers that we know are non-trade ones, and we can see for these where we've added our durable keys. So we've got customer 6 and customer 7 are actually the same customer, just at 2 points in history, and we can see we've got a proper durable key pulled through for those. So that concludes the demos. So in summary, why is this a good approach for making it simpler to query SCD type 2s? Well, it's a pattern-based approach, so it's easy for us to apply this to new development and existing developments. It offers a better user experience. It's simpler to write queries for end users, and those queries should perform better because they're doing less joins. The engine has to do less work. It gives us the easier ability to show people how to do those point-in-time views of dimensions, the as-was, and they're able to go in and apply more advanced querying techniques. For example, for a sales pipeline, you might want to use the change states on the dimension to say, well, when did the status of my potential work, my potential sale change, and use that to work out, for example, how much time has elapsed and work has been done on a sales opportunity between those statuses changing. Finally, there's the links for the slides, and there's a few other links for some things that we've touched on today. Once again, if you have any questions or any feedback for me, just ping me on the chat window, and it would be great to hear from you. Thank you very much.